November 14, 1965. Landing Zone X-ray, IA Drang Valley. Helicopters fade and the jungle closes in. A young lieutenant scribbles into a field notebook. The rifle in my hands just saved my life. But I watched 3 men die today because theirs would not fire. This is the story of how a promising new rifle, the M16, became a liability in Vietnam, why it failed, and how the fix reshaped U.S. weapons procurement for decades. The promise of a new weapon. The weapon that would be called the M16 began as the Armalite AR-15, designed by Eugene Stoner in the late 1950s. It fired a lightweight 5.56 by 45 mm cartridge at very high velocity, letting soldiers carry more rounds with less recoil than the 7.62 mm M14. Early special operations trials in the early 1960s reported controllable automatic fire and impressive terminal performance at jungle distances. The Air Force adopted it first for base security. Field feedback was positive when rifles were kept clean and fed with the propellant the design assumed. Decision point: from AR-15 to M16. In 1963, Defense Secretary Robert McNamara halted M14 production and pushed the AR-15 into mass procurement as the XM16E1 for the Army and the M16 for the Air Force. But the production rifle and its supply chain diverged from what had worked in testing. The original system had been validated with DuPont's IMR 4475 stick powder, tuned for a cyclic rate near 800 rounds per minute and for the rifle's direct gas system. The critical change: propellant swap. To meet wartime volume, ammunition plants shifted to WC-846 ball powder from Olin Matheson. Ball powder scaled easily and cut costs, but it burned differently. It produced higher and longer port pressures, driving more gas and residue into the action, and it tended to raise cyclic rate into the 850 to 1000 revolutions per minute range. Calcium carbonate used in ball powder deterrent coatings added to fouling. In a piston gun, this grime stays out near the gas system. In the M16's direct gas layout, it blows into the bolt carrier, locking lugs, and chamber every shot. A small cost cut with big consequences. No chrome chamber. Colt and Stoner recommended chrome plating the chamber and bore, common by mid-century for corrosion resistance and easier extraction, especially in tropical climates. Early Army production skipped chrome to save time and money and out of misplaced accuracy concerns for mass issue. In Vietnam's humidity and mud, bare steel chambers corroded and roughened. Under heat and fouling from ball powder, soft brass cases expanded and stuck. Extractors tore through case rims, leaving tubes of brass welded into chambers. The rifle was now a club until a cleaning rod could punch the case out. The self-cleaning myth and missing gear. Marketing language and early briefings described the rifle as needing minimal maintenance. Many conventional units received no proper cleaning kits at issue. Some soldiers were told the rifle was self-cleaning. In the jungle, that guidance failed. Clearing a heat-welded stuck case required a rod most patrols didn't carry. Under fire, 30 seconds with both hands on a rod is a lifetime. Battlefield reality. IA Drang and after. IA Drang, November 1965, showcased both sides. Elite, well-led units with fresher rifles, better training, and significant stocks of the original stick powder ammunition reported solid performance. The rifle's low weight meant troopers could carry 300 to 400 rounds. High cyclic rate delivered suppressive fire that helped hold LZ X-ray against repeated assaults. But IA Drang was not the average line unit's environment. As 1966 wore on and hundreds of thousands of rifles reached conventional infantry, fed almost exclusively with ball powder, reports of catastrophic extraction failures surged. A pattern emerges. How the failure happened in the field. The sequence repeated across battalions. 10 to 20 rounds into a fight, the chamber fouled. The extractor ripped through a case rim. The bolt tried to feed a fresh round into a chamber already occupied by stuck brass. The action locked out of battery. The forward assist, added over Stoner's objection, could not fix a sealed chamber. Soldiers begged families to mail bore rods and paintbrushes. Some carried captured AK-47s as insurance, favoring its long-stroke piston, looser tolerances, and indifferent reliability under mud and neglect. Systems fail as systems. Nothing mystical made the M16 bad. The weapon, ammunition, and maintenance doctrine formed one system. Mass adopting a new propellant, skipping chrome, and under-equipping troops broke that system. When the rifle later received chrome chambers, revised buffers, cleaner burning 5.56 loads, and real training with real kits, reliability rose sharply. But those fixes came after 1960 SIX's worst months, when trust had already collapsed. The reckoning to come. Letters, after-action reports, and casualty investigations reached Washington. In 1967, the House Armed Services Special Subcommittee on the M16 rifle program, chaired by Representative Richard Ichord, subpoenaed data and weapons and heard sworn testimony from Stoner, Colt, ammo makers, generals, and returning Marines and soldiers. The record would force the Army to change procurement, quality control, and field doctrine in a matter of months. The congressional reckoning. By 1966, the complaints could no longer be ignored. Letters from Marines and soldiers reached newspapers. Commanders filed formal reports. Casualty lists and eyewitness accounts described identical failures. Rifles that fired then locked up when needed most. Public outrage pushed the issue to Congress. A special House subcommittee was formed in spring 1967 to investigate the M16 program. Representative Richard Ichord chaired the hearings. The session schedule stretched for months. The room filled with soldiers, engineers, ammunition executives, ordnance officers, and weapons recovered from Vietnam. Testimony was sworn. Documents were subpoenaed. The committee reconstructed the failure chain step by step. Ballistics charts compared IMR 4475 stick powder, the propellant used during initial AR-15 testing, with WC-846 ball powder used in mass production. Experts showed higher peak and prolonged port pressures from ball powder. They demonstrated how the ball powder's calcium carbonate deterrent left sticky fouling that the M16's direct gas system blew into the bolt and chamber. Eugene Stoner testified that the AR-15 was engineered as a single, integrated system. Change the ammunition or ignore recommended materials and you change the system. Colt engineers had written warnings. Ammunition manufacturers had noted differences in burn characteristics. Army Ordnance had acceptance tests on rifles using the original powder even while millions of rounds loaded with WC-846 were shipped to Vietnam. The committee also examined production and procurement decisions. Chrome plating the chamber and bore had been recommended by designers and industry experts to resist corrosion and prevent case sticking in tropical climates. The Army elected not to chromeline production rifles to save time and money. Quality control records showed waived specifications and rejected parts that were nevertheless shipped to meet quotas. Witnesses described the logistics failure on the ground. Many units received M16s with no cleaning kits and minimal instruction. Training messages had circulated that the weapon required little maintenance. Soldiers in jungle conditions discovered otherwise. Clearing a case stuck from a corroded, foul chamber required a bore rod and time that combat rarely afforded. The forward assist, a feature added by Army requirement, became emblematic of the problem. It allowed a soldier to force a bolt home but could not remove a heat-welded case. Soldiers who relied on the forward assist under fire found their weapons still inoperable. Congressional testimony included vivid first-hand accounts. Marines described squads where multiple rifles failed simultaneously. One corporal reportedly died while trying to clear jams on other men's weapons. Letters from home, printed in evidence, pleaded for cleaning rods and brushes. The human cost became central to the committee's findings. The Ichord hearings produced hard recommendations. They identified the ammunition change as the primary cause of catastrophic extraction failures. They cited lack of chrome plating, inadequate training and cleaning equipment, elevated cyclic rates, and lapses in quality control as compounding factors. The political pressure left the Army with no credible option but rapid corrective action. Within months, procurement and production changed. Chrome plating was ordered. Buffer assemblies were redesigned to slow the cyclic rate. Cleaning kits and illustrated maintenance manuals were distributed. Acceptance testing and quality control were tightened. New propellant formulations with lower fouling characteristics were developed. The hearings did more than fix a rifle. They forced a shift in acquisition culture. Operational testing, soldier feedback, documented waivers, and independent oversight became part of weapons fielding. The M16 crisis became a case study in what happens when a weapon system is separated from its ammunition and maintenance requirements. The turning point, the M16A1 emerges. After the congressional hearings of 1967, the Army moved quickly to fix the disaster. The XM16E1 was reclassified as the M16A1, marking a new beginning. Engineers chrome-plated the chamber and bore, solving the corrosion and extraction problem. A redesigned buffer assembly reduced the cyclic rate and softened recoil, while improved extractor springs and stronger bolts increased reliability. These mechanical corrections transformed the rifle's behavior in the field. Soldiers began to trust it again. 2. The cleaning revolution. The Army admitted its previous mistake. The self-cleaning rifle myth was false. New training doctrine emphasized daily cleaning. A revised Field Manual 23-9 provided illustrated maintenance steps. PS Magazine, the Army's comic-style publication, taught soldiers visually how to strip, scrub, and reassemble their rifles. Cleaning kits were finally issued to every troop. Rods, bore brushes, chamber brushes, oil bottles, and pipe cleaners. By late 1967, entire battalions had received proper equipment. Inspections became routine. Platoon sergeants checked every weapon before and after patrols. Dirty rifles were punished as serious offenses. Improved ammunition and performance. In 1970, the new WC 844 powder replaced WC 846. It burned cleaner and reduced fouling. Combined with the chrome chamber, it eliminated most extraction failures. Malfunction rates dropped sharply. By early 1968. Surveys showed over 85% of soldiers satisfied with the M16A1's reliability. Troops who once begged for AK-47s now praised the M16 for its accuracy, low recoil, and lightweight ammunition load. Combat data confirmed it. Rifles that had jammed in 1966 were now functioning almost flawlessly in 1968. Redemption in the field. Veterans began to rewrite the story. By 1969, soldiers in the Mekong Delta and Central Highlands trusted the M16A1 completely. The same weapon that had once been a symbol of failure now became the standard of modern infantry firepower. Lightweight, accurate, controllable on automatic, and lethal within 300 meters. The rifle's true design finally matched its promise. By fixing the weapon, the Army restored faith not only in the rifle but in its ability to learn from error. Regaining trust. By 1968, U.S. soldiers carried rifles they could finally depend on. The M16A1 had proven itself reliable in the humid jungles and rice paddies of Vietnam. Surveys showed that more than 90% of troops preferred it to the M14. Fire discipline improved, ammunition load increased, and confidence returned. But the lessons from the M16's early failure reached far beyond the rifle itself. The scandal reshaped how America designed, tested, and purchased every weapon that followed. Reforming procurement and testing. The Ichord Committee forced lasting reforms. From 1968 onward, every new weapon required operational testing under field conditions before mass production. No longer could procurement rely only on laboratory or range results. The Army also created the Product Quality Deficiency Report System, allowing soldiers to officially report equipment failures. These reports were logged, investigated, and could trigger design changes. The principle was clear. Feedback from the field was no longer anecdote, it was data. Waivers for failed quality tests became rare. Every modification had to be documented and approved at senior levels. Inspectors gained authority to reject shipments that didn't meet specifications, regardless of production pressure. Culture change. Listen to the soldier. The M16 debacle proved that the opinions of soldiers on the ground mattered more than optimistic memos from offices. The Army institutionalized user evaluations for all future equipment. Soldiers would test new gear, record performance under combat stress, and those results would decide whether a system advanced or was redesigned. Weapons were now viewed as ecosystems, rifle, ammunition, maintenance, and environment as one. The idea that cost-cutting could be separated from reliability was permanently discredited. Long-term impact. From failure to standard. By the 1970s, the M16A1 had evolved into the M16A2, and later into the M4 carbine, direct descendants of Stoner's design. Each improvement traced back to lessons learned from Vietnam. Better materials, improved propellants, tighter quality control, and constant soldier feedback. Today, the M16 family has served U.S. forces for more than half a century. What began as a catastrophic failure became one of the longest-serving and most influential rifle platforms in modern history. Final message. Failure as teacher. The M16 story is both tragedy and triumph. Hundreds of soldiers died with jammed rifles. Yet those losses forced transparency and reform that saved thousands in later years. Every chrome-plated barrel, every standardized test, every improved cleaning kit owes its existence to men who fought and fell in 1966 to 67. Their sacrifice turned a flawed rifle into a global standard and forced a powerful institution to listen, learn, and adapt. The M16's legacy endures not because it was perfect, but because America finally admitted it wasn't. Epilogue. The rifle that taught a nation. 1. From failure to foundation. The M16 story did not end in Vietnam. Its DNA runs through every rifle the U.S. military has carried since. The M16A2 refined the design for the Cold War era: heavier barrel, burst fire selector, better sights. The M4 carbine, a compact descendant, became the symbol of modern U.S. infantry from the 1990s through Iraq and Afghanistan. Every improvement, cleaner propellant, modular rails, better optics, stemmed from the lessons of 1966. The Army learned that no design, however advanced, survives bad assumptions or poor testing. The M16 taught the U.S. military that reliability starts with honesty. 2. A weapon and a warning. The rifle's early failures became a cautionary tale in every defense program that followed. Before the M16 crisis, military procurement was driven by statistics and production quotas. Afterward, every new weapon faced the question, will it work for the soldier in the mud? This shift protected future generations. Testing became stricter, oversight deeper, and field feedback permanent. The M16's failure forced the Pentagon to value the user as much as the engineer. 3. The human cost and legacy. Hundreds of soldiers died with jammed rifles in their hands. They were victims not of design flaws alone but of bureaucracy and denial. Yet their experience transformed how America equips its warriors. The Ichord hearings turned private tragedy into public accountability. They proved that transparency and pressure from outside the chain of command can save lives. Every modern soldier carrying a clean, functioning weapon owes something to those who fell when their rifles did not. 4. The final lesson. The M16 began as a promise of innovation, failed through neglect, and redeemed itself through reform. Its history reminds us that technology alone cannot win wars. Only disciplined systems, honest evaluation, and the courage to admit error can. In the end, the M16 became more than a rifle. It became a mirror showing what happens when institutions ignore their own data and how they can recover when they finally listen. The soldiers who fought with the early M16 paid a terrible price. But their sacrifice forced the U.S. military to build a culture that listens, tests, and fixes. The rifle that once betrayed them now stands as proof that even failure, if faced openly, can build something stronger.